Good morning, students. Am I audible? Okay. Okay. Then we start. Okay. It's already 10:06. So in last class we have solved a numerical. Okay. So related to your energy coefficient, momentum coefficient, and average velocity. So we are going to solve few more problems related to your energy coefficient, momentum coefficient, and your average velocity. Okay. So our next question is example 1.2. Okay. So here is also given a rectangular channel where the depth of flow in that particular channel is 2 meter. Okay. And for that velocity for the small elementary area, it's given by an equation, that is y by y naught to the power half. Okay. So if you remember, before we solve or before we calculate alpha and beta, we need to calculate average velocity. So we have taken average velocity equation, okay, for rectangular channel. So this equation we have already derived. Okay. So it's better if you take a pen and paper and you try to solve. Okay. So for average velocity, that y naught value is given 2 meter. This is your 2 meter. Okay. The depth of flow in that particular channel is 2 meter. So the depth of flow in that particular rectangular channel is 2 meter. Okay. That is given. So y naught value is 2. Y naught is equal to 2 and it's given in the question. Okay. So now in this equation we are going to substitute y naught is equal to 2. So here that is why 1 by 2, and again limit it's from 0 to 2, as if you remember we have already derived that limit will be from 0 to the maximum depth, and here in this question our maximum depth is 2. So that is why our limit is from 0 to 2. Then y by again y naught value we have replaced by 2 to the power half dy. Okay. Now if you solve this equation you will get 2 by 3 meter per second. How you are going to solve? We have half multiplied by, again this is also one constant, 1 by 2 to the power half. Okay. Then we have integration 0 to 2 by to the power 1 by 2 dy. Okay. So again 1 by 2 to the power 3 by 2. Okay. And then now you integrate. If you integrate this, y to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay. So what will be your answer? It will be y to the power, sorry, this is 1 by 2 to the power 3 by 2. Okay. So here we have limit 0 to 2. Okay. So once you solve here 1 by 2 to the power 3 by 2, then this will come up 2 by 3 multiplied by 2 to the power 2 by 3 by 2. Okay. So this will be cancelled out. What will be left out is 2 by 3. Okay. Understood? Or if you want me to repeat, if you want to repeat, then I can repeat again. Okay. Very simple. Okay. Wait, I will repeat once again. How to solve this? B is equal to half is already there. Okay. Multiplied. As 2 is your constant, so we are not going to integrate the constant term. Okay. It will be, we are going to bring it out. Okay. So we have, don't forget this, we have to the power half. Okay. So whatever it will be, it's 2 to the power 1 by 2. Okay. Then we have to multiply. Then we have to do the integration. Okay. So what will be left out? Integration from limit 0 to 2 y to the power 1 by 2 dy. Okay. So again, if you solve 1 by, this is 2 into 2 to the power half. It is 2 to the power 3 by 2. Okay. Then multiplied by, again, if you do the integration, it will be y to the power half plus 1 divided by half plus 1. Okay. And then we have limit 0 to 2. Okay. Then again, if you solve, it will be 1 by 2 to the power 3 by 2 multiplied by, it will be y to the power 3 by 2 divided by 3 by 2 limit 0 to 2. Okay. So again, if you solve, it will be 1 by 2 to the power 3 by 2 multiplied by, if you bring out, it will be 2 by 3 multiplied by, if you remember, we have to substitute first the maximum limit, then minus the 0 to the power 3 by 2. So 0 to the power 3 by 2 will be 0. So what will be left out is 2 to the power 3 by 2. Okay. So this 2 to the power 3 by 2 and this 2 to the power 3 by 2 is will be cancelled out. Okay. What will be left out is 2 by 3. Okay. So what will be left out is 2 by 3. So your average velocity, so your average velocity is 2 by 3. Okay. So your average velocity is 2 by 3. As this is your velocity, so that is why the unit is meter per second. Okay. Okay. So similarly, you try to find out, similarly, you try to find out alpha value. Okay. Similarly, this equation we have already derived. This is for rectangular channel for energy coefficient. Okay. Here also, in place of y naught, you substitute 2 meter that is given in the question. So 1 by 2, limit you set 0 to 2. Then in place of small v, we are going to use this equation. Okay. In place of small v, we are using this equation which is given in the question. Okay. So here y by 2, as we know y naught is already 2, it's given. So that is why your v will be y by 2 to the power half. So that's what we are going to substitute here. Okay. And in place of v, capital V, we have substitute 2 by 3 that we have already calculated. Okay. And then you do the integration. Always remember you bring out the all the constant term as 1 by 2, then 2 by 3 is also constant. Don't remember that we have a cube here. Okay. So that is why 2 by 3 whole cube. Okay. Then integration of y by 2 whole to the power as 1 by 2 multiplied by 3, so 3 by 2. Okay. And then you find out alpha. Okay. So try to find. Okay, and check it's coming or not. Okay. Okay, so you try to solve this alpha and see if this value is coming or not. If it is not come, then I'm going to solve again. Okay. Okay, only in this equation what you have to do is in place of y naught you have to substitute 2, which is given in the equation. For small v, in place of small v, we are going to substitute this equation y by y naught to the power half. As y naught is again it's given 2 meter, so that is why y by 2 to the power half. Okay. And in place of average velocity, we have already calculated that average velocity 2 by 3. So you substitute here 2 by 3 whole cube. Okay. Whole cube. Then you do the integration, you bring all the constant term out and you integrate the y, and I'm sure you are going to get this answer 1.35. So you are getting that value 1.35. So if you are getting that value, then we are going to proceed. Okay. Okay. So now we are going to proceed to your momentum coefficient, that is beta. Okay. So again, this equation we have already derived. So remember, always remember this equation what we have used. This is only for rectangular channel. Okay. This is for rectangular channel. Okay. So we have derived this equation. So similarly here also in place of y naught, we are going to substitute 2 meter, and in place of small v, we are going to substitute y by y naught to the power half. Okay. In place of small v. Okay. And in place of capital V, we are going to substitute 2 by 3 that we have already calculated. Okay. Here we have already calculated the average velocity. And similarly, we are going to substitute here, similar to your previous case. And then we are going to integrate and see if you find out the value is 1.125 beta. So you are getting the value beta 1.125. If you got that value, then we are going to proceed. Or if you have any doubts, you can ask me. Okay. So those are very simple. When you proceed, it will come with more complex. Okay. So that's why I'm repeatedly asking you if you have any doubts, then it's better to clarify now. Okay. So see, those what we have discussed today, those are solved. Okay, it's in your exercise, sorry, it is in your example. So what we are going to do, those are simple questions, so we are going to do some complex, those are in your exercise. So what I want to suggest, those are not, okay, questions are not here. Okay, sorry for delay. So we are going to solve uh, questions 1.5. Okay, so the solution of these questions is not there, okay, in the PDF that I have given. Okay, so I suggest you to kindly do the solve these questions in your paper. Okay, so what here is given, what is given, the velocity distribution. Okay, fine, here is also given a rectangular channel. Okay, distribution in a rectangular channel, and the equation is given, this is for your small v. Okay, now small v is your 0.4 plus 0.6 y by y naught. Okay, okay, and y naught value is given 1 meter. Okay, and what we need to find out, average velocity, alpha, that is energy coefficient, and beta, that is your momentum coefficient. Okay, so definitely we have to first, we have to solve for average velocity. Okay, So what is the average velocity equation for rectangular channel? It's 1 by y naught integration 0 to y naught v dy. Okay. So what we are going to do here, we substitute the value of y naught by 1 meter and is given. Okay, y naught is 1 is given. Okay. So it's multiplied by, in place of v, we are going to here also the limit from 0 to 1 as y naught is given 1. Okay, and v, for v we are writing this equation 0.4 plus 0.6 y by y naught. Okay, so here in place of y naught we can write again 1. Okay, as y naught is equal to 1 is given in the question dy. Okay, so now you solve. So this 1 it will be 1. So then again you have, in such case you have to divide, as this is your addition, it is not your multiplication. So what we have to do, you can skip this step. Okay, if you understand, 0.4 dy plus 0 to 1 0.6 y dy. Okay, you have to integrate in separately. Okay, you can consider a and this is b. Okay, so you have to separate, we integrate a and b. Okay, if it is a multiplication, then it's no issue, you can bring out the constant term. If it is addition, you cannot do that one. Okay, so again, if you integrate this, constant term will be 0.4 integration of dy. Okay, from 0 to 1, integration of dy from 0 to 1 plus, here constant term is 0.6 integration of y dy, limit is 0 to 1. Okay, after that, okay, next is, after this, come here. Okay, again, if you integrate this, it will be 0.4 multiplied by y. Okay, integration of dy is y, then we have limit from 0 to 1 plus 0.6 integration of y is y square divided by 2, and again you have limit 0 to 1, 0 to 1. Okay, then this will be 0.4 multiplied by, your maximum limit is 1, so you substitute here 1 minus, it will become like this, minus 0. Okay, so here 0, 1 minus 0 is 1, so you can directly write 1. Okay, you can skip those steps. Okay, plus 0.6 multiplied by, here y square and this 2, so this will be 1 by 2 multiplied by, again it will be 1. Okay, It will be, you cancel it out, it will be 0.3 to the 6. Okay, 0.3. So it will be 0.7 meter per second. Okay, so our average velocity for that particular question, for this particular question, is 0.7 meter per second. Okay, okay. Any doubts? You all have followed now. Okay, so now we will go for alpha. Okay, so you can see here 0.7 meter per second. So you are getting the same value. Okay, that means what we have done, it's correct. Okay, see, I did in a longer way, so you can skip few steps. Okay. Okay, so to make you better understand, I did more steps. Okay, so you can skip some of the steps if you want. Okay, so next you go for alpha, and if you remember, alpha equation is 0 to y naught small v divided by capital V whole cube, then 1 by y naught dy. Okay, so you try to find out the alpha value. If you have any problems, then you let me know. Okay, then alpha should be 1.18. Okay, in place of y naught we need to substitute 1 meter. Okay, and for small v, again we have to substitute this equation. Okay, so you, whatever you are going to do, it's do click carefully. Okay, and then in place of average velocity we are going to substitute 0.7 that we have already calculated. Okay, so here again, this why not, if you substitute here 1, this 1 will be cancel out. So what will be left out is 1 by 0.7 whole cube. Okay, as your capital V average velocity is zero point 0.7. So here we have cube. Okay, so if you bring it out, it will be 1 by 0.7 whole cube. Then we have integration 0 to 1. Okay, and then we have substitute the equation for small v. Okay, plus 0.6 y by y naught. Okay, as y naught is again 1 in this equation, y naught is again 1, so we can directly write 0.6 y. Okay, then don't forget we have a cube. Okay, dy. So to solve this equation, first we have to take a plus b whole cube. We have to take this equation. Okay, we have to take this equation a plus b whole cube. Okay, first we have to break this, then only we can do integration. Okay, then only we can go for integration. First, before going integration, we have to break this as a plus b whole cube. So we all know is a cube plus b cube plus thrice a square b plus thrice a square ab square. Okay, so you all know what is a plus b whole cube. You substitute here. Okay, it's not visible. Okay, then I think Kaputara. I think there is some network problem in your place. Okay, okay. So to break this 0.4 plus 0.6 y to the power cube as a plus b whole cube, and then you start solving. Okay, so it's a little bit difficult to solve here, but still I'll try. Okay, so we have again integration 0 to 1. Then we have a cube, that is 0.4 whole cube. Okay, a cube plus, then we can this b, you can consider this is as a and this is as b. Okay, so a cube plus b cube, so 0.6 whole cube, and then we have y cube. Okay, plus thrice plus 3 multiplied by a square, that is 0.4 whole square multiplied by 0.6 y. Okay, this is multiplied. Okay, don't confuse, this is multiplication. Okay, then we will be having another one term. Okay, That is our 3 multiplied by 0.4 multiplied by 0.0.6 by whole square. So 3a square b plus 3ab square. Then again we will be having limit from 0 to 1. So it's already given. We don't have to give that limit again. Okay. dy. Okay. Then we have dy. So if you solve further, it will be 1 by 0.7 whole cube multiplied by, so 0.4 whole cube, it will be, I think, 0.064. Okay. 0.064, it's correct. Okay. 0.6 whole cube. 0.6 whole cube. You can use your calculator. Okay. 216 y cube. Okay. Y cube plus multiply 0.4 whole square multiplied by 3, you will get a value of 0.288. If you do this calculations for 0.4 whole square multiplied by zero point 0.6 multiplied by zero point 0.3, you will get 0.288 y. Okay. Then addition, we have another one term, that is 0.6 whole square multiplied by 0.4 multiplied by 0.3, you will get an approximately 0.432. And we have y to the power whole square, so we will be having y square here. Okay. Limit from 0 to 1 dy. Okay. So we are running out of time. So okay, so we are about to end our first class today. In second class, we have another one from 11. So we are going to continue this problem in the next class. Okay.